This is number 15 from the January 2019 Regents. The answer is number 3. All right, so of course you can plug in your values and you can check to see if these values work in the original equation. I'm going to solve this directly so you can see how to solve a rational equation. Okay, so first thing I need is the LCD. So the LCD of this is 3x plus 1. So I collect the first denominator. X is something else, so I'll have to add that to my LCD. And then 3x plus 1 I already have. All right, so now I'm going to take my LCD. I'm going to place it on the top only so that I can clear the denominators and make this something easier to solve. Okay, so this is my equation. All right, so on the first term, I'm putting the x and the 3x plus 1. So just on the first term, 3x plus 1 crosses off, and I have 2 times x, which is 2x. All right, on the second term, just the x crosses off. So I have equals 1 times 3x plus 1, so 3x plus 1. And on the last term, the 3x plus 1 crosses off, and I have minus 6x squared, because 6x times x. All right, so this is a quadratic, so I need to set it equal to 0. I'm actually going to move everything to the left because I like my leading term to be positive. So I'm going to subtract the 3x. I'm going to subtract the 1. And I'm going to add the 6x squared. All right, so I'm going to put it in the right order. I have 6x squared. 2x and negative 3x is negative x. Minus 1 equals 0. All right, so now when I solve this, I'm going to use AC grouping. So I'm looking for the factors of negative 6 that give me a negative 1. So negative 3 and positive 2. So I split the middle term to be negative 3x plus 2x minus 1 using these factors. Okay, split it up into a grouping problem. I have a 3x in common. I have 2x minus 1. Here I have a 1 in common, 2x minus 1. Here's my GCF. So I write the GCF, and then I write the leftovers inside of their own parenthesis. Okay, teeing this off, I'm setting equal to 0. I get 2x equals positive 1, because I add the 1 to the other side. Divide by 2, I get 1/2. And then 3x equals, I subtract the 1 to the other side, negative 1, negative 1/3. Now, be careful, that's one of your answer choices. But because we have a rational equation, we have to throw out any of the answer choices that make the original fraction undefined. So if you plug in negative 1/3 into one of the originals, so I'll just show you in the first one. When I plug in 3 times negative 1/3 plus 1, I actually get a 0 in the denominator, which is not good. So I have to throw out this negative 1/3, and I have to keep only the 1/2.